Hi, my name is David Brook from HCC Embedded. We're here at the Embedded World Show in Nuremberg, demonstrating a completely fail-safe SD card-based embedded file system. In this system we have a fully reliable and robust fail-safe design, which not only depends on the software but also depends on the special hardware features designed into the SD card by our partner Swissbit. In this demonstration here we have Swissbit's industrial SD card controller running on an embedded microcontroller design, and we're comparing that to a non-fail-safe system which uses a fully traditional FAT file system with a generic SD card which can be bought in any electronics store. In the operation of this system we introduce errors to the communications line using electronic relays, and we disturb the read-write operation of the file system. And the result of this operation is that we have many thousands of read-write operations which have been disturbed and from which the fully fail-safe system has recovered. However, the non-fail-safe system, which uses a free FAT file system and a generic SD card, has a very high percentage of file corruptions and failures which we've recorded on this demo system here. I'd like to introduce my colleague Pablo from Swissbit. And Pablo, could you explain to me the benefits of using a mechanism to ensure the power fail safety in an SD card?
Sure. So basically when you use our card, what we can guarantee is that in the case of a power fail event, when you read back the data that you were writing after power fail came, you get no wrong data. Either you get the data you had for this address before the power failed, or you were lucky and then you get the new data. But there is no corruption of static data, there is no in-between state that you get wrong data. So basically what the key concept for this is the firmware running on the controller. When you write some data to a sector, it guarantees that the old data is still running around in the card. And when you power the car on, it's going to detect if there was a power fail issue or not. And if there is a power fail issue, it will scan the data and see if the data is okay or not. In case the data is not okay, the new data that was being written, it's going to be discarded and then it's going to take back the old data.
Okay.
So basically, whenever you have a power fail event, you get no wrong data. You get either the data you had before power fail or the new data.
So there's no uncertainty any time, no. Even if power interruptions or communications interruptions
there is no static data corruption and no uncertainty.
Okay, Pablo, thank you very much.
You're welcome.
I'd now like to speak to Dave Hughes, the CEO of HCC Embedded, about the importance of a system-level approach to ensuring a robust file system and data integrity. Dave, could you perhaps start by explaining the importance of a system-level approach to a file system which is going to guarantee data integrity?
Well, probably the best way to start is to look at this demonstration. If we were to swap over the reliable card from Swissbit and the generic SD card, we'd actually find failures in both systems, be it our failsafe system and also on the free file system. And the reason for that is that you need to have a complete architecture from the top level to the physical layer. You have to have an understanding of what fail safety means and what the requirements are from each level working your way down the stack. It's clearly pointless to have a very reliable file system and a media that is totally unreliable. And that's just logically fairly obvious. And you have to structure that all the way up to the application layer, so even the application understands what it's getting from the file system and what fail safety means at that level. And so when we say there's failures on both systems, using a reliable card with an unreliable file system will reduce the errors. Using an unreliable card with a reliable file system will reduce the errors. The only way to guarantee from application down to your data that everything is going to be fail-safe is to architect the whole system in a fail-safe way where each level understands the requirements of the layer below.
Okay, so the hardware has to have a set of requirements which the software is aware of, and in turn the software has to provide services for the hardware in order to ensure that from top to bottom the whole system is robust by design.
Absolutely. I mean, clearly in any design, if one layer doesn't understand what is given to it by another layer, there's no way that it can be considered a reliable layer, or it can expect what's going to happen next. So you have to understand every single layer. The commercial SD cards we use here do not have any specification or statement about what level of service they will guarantee. Whereas the Swissbit card does very clearly state what level of service it gives. It gives absolutely reliable, either the write is complete or the reliable is not complete. If we know in a brownout situation it handles it cleanly, and therefore we can start to design the next level up of the system, and which is then the file system which is using that card.
Yeah. So the system by design is completely fail-safe, and the data is completely reliable.
Exactly.
Okay, Dave, thank you very much. Hopefully that is a good introduction to the most important requirements in designing an embedded system which is high quality and guarantees reliable data by design. The subject is complex, and on the HCC website at www.hcc-embedded.com there is some very detailed technical information, and HCC engineers are always willing to have deep technical discussions, so visit our website and find out the best way to deal with reliable data protection.